We all know the formula for a circle's area. A equals PIR squared. It seems simple, right? But have you ever wondered why this formula works the way it does? Let's break it down step by step to understand its beauty and logic. This formula tells us how much space is inside the circle. Imagine filling the circle with tiny squares. The formula helps us count all those squares. The star of the show is r, which stands for the radius. The radius is crucial because it defines the size of the circle. The radius is the distance from the circle's center to its edge. It's like the circle's personal measuring tape. We square the radius r times r. This squaring process helps us understand how the area grows as the circle gets larger. Then we multiply that squared value by pi. Pi is a magical number that scales our squared radius to fit the circle perfectly. Pi is a special number, approximately 3.14. It's an irrational number, meaning it goes on forever without repeating. It represents the constant ratio of a circle's circumference to its diameter. This ratio is the same for every circle, no matter how big or small. So the next time you see the formula A equals PIR squared, remember it's not just a bunch of symbols, it's a beautiful relationship that helps us understand the space within a circle. What if we make pi the radius itself? This might sound unconventional, but let's explore the possibilities. Imagine a circle with a radius of 3.14 units. This is not just any number, it's the mathematical constant pi, which is approximately 3.14. It's unusual, but it helps us understand the formula better. By using pi as the radius, we can see the relationship between the radius and the area of the circle in a new light. Our formula, A equals pi r squared, now becomes A equals pi times 3.14 squared. This transformation allows us to delve deeper into the concept. We are squaring 3.14, which means multiplying it by itself, 3.14 times 3.14. This calculation gives us a new perspective on how the area of a circle is determined when pi is used as the radius. It's a fascinating twist that opens up new ways of thinking about geometry and mathematics. Squaring pi might feel like we're cubing a number, but let's break it down to understand the difference. We're multiplying 3.14 by itself twice. Essentially, we're performing the operation, 3.14 times 3.14. But there's a difference when it comes to cubing. Cubing a number means multiplying it by itself 3 times. This is a fundamental concept in mathematics. For example, 2 cubed is 2 times 2 times 2, which equals 8. This is straightforward and easy to visualize. In our case, we're squaring pi, which means multiplying 3.14 by 3.14. This gives us a new value. After squaring pi, we then multiply the result by pi again. This is a two-step process that is different from simply cubing the number. This is not the same as cubing 3.14. Cubing would involve multiplying 3.14 by itself 3 times in one continuous operation. Instead, we first square it and then multiply by pi, making it a distinct and separate calculation. Using pi as both the radius and a constant in our formula highlights its fundamental importance. It shows how pi connects a circle's dimensions and its area seamlessly. The formula A equals PIR squared elegantly captures this unique relationship. Even when the radius is pi itself, the formula holds true. The area calculation involves both squaring the radius and incorporating the constant pi. This ensures we're calculating the area accurately and precisely.